Welcome to the 37th lecture on electronic circuits design ECD. In the last lecture, we studied expressions for input and output impedances for a non-inverting amplifier based on op-amp. In this lecture, we will study the voltage follower circuit and will study its Z-in, the input impedance, and its output impedance. The expression that we computed for a non-inverting amplifier for Z-in is this. Since a voltage follower is also a non-inverting amplifier, except that we don't have any RF, or RF is 0. So putting in this expression RF is equal to 0, RF is equal to 0. So this leaves us to the ratio where Ri is divided by another Ri, or Ri divided by Ri. So they cancel and the answer is a 1. So 1 plus 1 times AOL, open loop gain. So 1 plus AOL times Jn. So even this is fairly high. In fact, it is higher than the Z-in that we computed for Ni, for non-inverting amplifier, because this ratio would yield an answer that is smaller than 1. So here we are, in that case, in the case of non-inverting amplifier, we multiply AOL with a ratio that is smaller than 1, and here we multiply it with a 1. So this answer is greater than this answer. So Z-in of a voltage follow is slightly larger than Z-in of a non-inverting amplifier. Right, let's move on to the Z out. The Z out for a non-inverting amplifier we studied in last lecture was this. But you know that RF is 0, so RF, replacing RF with a 0, we are left with Ri over Ri. So Ri gives us a 1. So the expression is this, right? So this is very simple, very simple. If we know the expressions for Z in and Z out for a non-inverting amplifier, we can straight away compute the expressions for Z in and Z out for this voltage follower circuit. The next thing that we will study in this lecture is inverting amplifiers, Z in and Z out. Right, we know that for an inverting amplifier we apply input to the inverting terminal through a resistor Ri, and we connect the non-inverting input to a ground. But if we connect this non-inverting input to ground, since there is a differential amplifier as the first stage of this amplifier, of this operational amplifier, so even the other terminal, the inverting terminal, is also taken to ground, that is virtual ground. This means that the voltage is equal to 0 volts, but it is not physically or actually connected to ground. So therefore it is called a virtual ground. We studied virtual ground in one of our previous lectures when we studied differential amplifier. Z in of Ni, if this is ground, this means the impedance from the input terminal to ground is of course Ri. So Z in is approximately equal to Ri. That's simple. But computing its expression for the output impedance is quite complex. So we are omitting it. We will not discuss the derivation here, but I'll tell you that we reach to, after a bit complex derivation that we won't discuss in this lecture, we reach to the same value Z out that we reach to in case of the non-inverting amplifier. So it's the same. Z out for inverting amplifier is the same as the Z out we studied for non-inverting amplifier, but the derivation is a bit complex, so we won't discuss it here. Right, so it is the same as it was for a non-inverting amplifier. Right, to end this lecture, we are going to solve an example where we are given a an inverting amplifier. The input is applied to the inverting input through resistor Ri, and there is a feedback resistor Rf equal to 100 kilo ohms. Ri is 1 kilo ohms. The non-inverting terminal is connected to ground directly. And these are some datasheet parameters given. Z in for this op amp in open loop, this is 4 mega ohm. The open loop output impedance is 50 ohms, and AOL, the open loop voltage gain, is 50k, means 50,000. This k means 1,000, 50,000. So what is Zn? You know that Cn is approximately equal to Ri. The input resistance is 1 kilo. This is simple. The next thing is Z out. To compute C out, we have to use the same expression that we used for non-inverting amplifier. Putting these values, C out is 50, the open loop impedance, the impedance of the op amp, 50 over 1 plus Ri is 1, Rf is 100 times 50k, 50,000, the open loop gain. So this gives us a Z out equal to 980. 980, it's not mega, it's milli. It's milli. Means 10 to the minus 3. It's not meg, it's milli. So it's milli. It's very small resistance. MILLI, milli ohms. So a very small output impedance, almost zero. So it's a good amplifier, giving us a very small output impedance and a very large input impedance, not very large, but fairly large. Right, so ACL for this inverting amplifier we have already studied it. Its expression is minus RF over I. It's inverting, means the output is inverted compared to the input. So this is computed as a ratio between RF over RI. So this gives us ACL inverting minus 100. So that's all for this lecture. In the upcoming lectures, we will keep on studying the basics of operational amplifiers. Thank you.